In chapter 6, we will talk about systems of linear equations, and we're going to talk about three different ways of solving a system. So first off, what is a system of linear equations? A system of linear equations is a grouping of two or more linear equations where each equation contains one or more variables, usually in the form of y equals to mx plus b, or in the form of ax plus by equals to c. Now, a solution to a system of equations is values for the variables that satisfy each equation of the system. Okay, so a solution, in short, is an ordered pair xy. So this is an ordered pair xy, so that when you plug it in, this pair satisfies both equations. And by satisfy, I mean when you plug them in both cases, the left side and the right side are equal. So for example, determine whether negative 416 is a solution to the system of equations. So negative 4 is the x value and 16 is the y value. So to check to see if this is a solution, we're going to plug it in to both equations. So the first one is y equals to negative 2x plus 8. Now, since the x value is negative 4 and the y value is 16, what we're going to do is we're going to replace the y value with the 16. Everything else we keep the same, the equal sign, the negative 2. But then when we get to the x value, that x value is going to get replaced with a negative 4. And then we still have the plus 8. So the x and y's got replaced with the respective values, which are negative 4 and 16. So here we get 16, negative 2 times negative 4 is positive 8. Remember that a negative times a negative is positive. And we get 16 equals to 16. Since the left side and right side are equal, this satisfies the first equation. But now we want to check, for this point to be a solution, it has to satisfy the second equation also. The second equation is 2x plus y equal to 0. So let's replace the x value with a negative 4. Remember, the same point has to satisfy both equations, the second one as well. So we're going to replace the x value with the negative 4. Then we have a plus sign. And then the y value, we're going to replace this with a 16. And now you want to check, is that a true statement? In other words, is the left side and the right side equal? So 2 times negative 4 is negative 8. Negative 8 plus 16, we want to know, does that equal to 0? Negative 8 plus 16 is positive 8. Now 8 does not equal to 0. That is a false statement. So the second equation is not satisfied by that point. So this point is not a solution. Next example, determine whether the point 2, negative 8 is a solution to the system of equations. So we did the exact same thing. This time I'm going to go a little bit faster. Our x value is 2, our y value is negative 8. So we have negative 3x. Instead of x, I'm going to put a 2 there. And then plus we have 4 times negative 8. You want to know, does that equal to negative 38? The second equation is 2x. So instead of x, I'm going to replace the x value with the 2. And then you have minus 5 times negative 8. I replace the y value with the negative 8. And I want to know, does that equal to 44? So we get negative 6, and then this is a negative 32. Negative 6 minus 32, that is negative 38. So negative 38 does equal to negative 38. That's good. Over here, we have 4, and then negative times a negative is a positive 40. So 44 does equal to 44, which also means that it is a solution. So because the same point satisfies both equation, then yes, it is a solution. Let's take a look at the first way of solving a system of equations. So the first method is by graphing. Now here are the steps. Graph the first equation. Just a reminder, to graph equations, we have to get the y by itself, and then we have to graph the y-intercept, and we have to use a slope to get more points. So we graph the first equation, graph the second equation, and then see where they intersect, because a point of intersection is a one point where it will, if any, and sometimes you have infinite number of points. But for now, we're going to focus on one point where that point satisfies both equations. Okay, so let's take a look at an example. Y equals to 3x minus 5. So in this case, our slope m is equal to 3, and our y-intercept b is 0, negative 5. Now we always start with the y-intercept when we graph a line. So the y-intercept is 0, negative 5. We start here. And our slope m is equal to 3 over 1, which means the rise is 3 and the run is 1. And again, the y-intercept, this is equal to 0, negative 5. So from here, I'm going to go up 3. So from the point 0, negative 5, I'm going to go up 1, 2, 3, and I'm going to go across 1. So my rise is 3 and my run is 1. So once I do that, I have my point. Now do it a couple more times. So go up 3 over 1, go up 3 over 1. And once I have a bunch of points, then I can connect them and make my line. Okay, let's take a look at the second one. Our second equation is y equal to negative 2x plus 5. So our slope m is negative 2, and our y-intercept is 0, 5. So for the second line, our slope m is negative 2 over 1, which is our rise over run. And then the y-intercept b is equal to 0, 5. So for the second line, this one I'll do in a different color. I start with 0, 5, so it's 1, 2, 3, 4, 5. And remember, the y-intercept is always on the y-axis, not on the x-axis. I labeled the y-axis for you guys. Our slope is negative 2 over 1. So from here, we're going to go down 2. So this is negative 2. And then over 1. Okay, so we're going to go down 2 and over 1. And do the same thing again. You go down 2 over 1. We go down 2 over 1. Do it a few times. Now notice that those two lines, they intersect at this point. And that point is a point 2, 1. So the x value is 2 and the y value is 1. So our solution is going to be the point 2, 1. And I'm not going to do this, but for a quiz, you should be checking your answer. So, first equation is y equal to 3x minus 5. So instead of y, replace it with the 1. And instead of an x, replace it with the 2. And see, is the left side equal to the right side? Then do the same thing for the second equation. The y value is 1, so you're going to put 1. Then you have a negative 2 times x, which is 2. And then you have plus 5. So once again, see, does the left side equal to the right side? And if that's the case, then you know you did it correctly. Okay, here's another example. We have y minus x equal to 1. So if you look at the steps, when you graph a line, you have to get the y by itself. That's your initial step. You have to get the y by itself. So to get the y by itself, so our first line is y minus x equal to negative 1. To get the y by itself, we have to move the x to the other side, which means we have to add x to both sides. So this gives you y equals to x minus 1. That's my first line. My second line, which is y equals to 2x equals to 5, I need to subtract 2x from each side. So I'm going to get y by itself, then this cancels out, and it'll be negative 2x plus 5. So for each line, I'm going to highlight my slope. So my slope is 1 over 1, which is my rise over run. My y-intercept is 0, negative 1. This is my b. For my second line, my slope is negative 2 over 1, which is my rise over run. And my y-intercept is 0, 5. So let me graph both lines. My first line, I'm starting off with a negative 1. My 0, negative 1. So remember, it's always on the y-axis. On the y-axis, you start with 0, negative 1. And the slope is 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Do it a few times until you get a nice straight line. Well, mine's not straight, but hopefully you guys can draw better than I can. The second one, our y-intercept is 0, 5, so I'll use a different color. You have 1, 2, 3, 4, and 5. This is 0, 5. And then from here, my slope is negative 2 over 1. So I'm going to y-intercept is 0, 5, and my slope is negative 2 over 1. So from 0, 5, always start at the y-intercept on the y-axis. We're going to go down 2 and over 1. And then once again, we're going to go down 2 and over 1. So this is going to be my line. Coincidentally, it is the exact same solution as last time, which is a point 2, 1. That's where they intersect. So that is my solution. Now, there are three types of systems of equations. Number one, when we have one solution where they intersect at one point, if they don't intersect anywhere, they're inconsistent, which means, remember, our solution is where they intersect. If the lines are parallel and they never intersect, that means that there is no solution. And if the lines coincide, which means they overlap, they intersect everywhere, so in this case, they are going to be infinite solutions. So think of any questions you guys may have, and please come to class prepared with questions.